No, don't take a picture. Okay. Where's the mode? Is everybody kind of with what this is happening? So it's sort of like these are a bunch of little rectangles, right? Just really small. So the height of the rectangle tells you that's what occurs the most. So where's the mode at? Yeah, the peak, right? So that would be the mode, right? Whatever the number that is. Which one's bigger? The median or the mean? Which one would be bigger? Well, which one's affected by the outliers? The mean. So the fact that this has been pulled this direction, do you see what I'm saying? So this is like taffy, and it used to look like a nice normal curve, and then somebody went, no, and then just pulled it like that. Right? And so the fact that these are extreme values, the median is going to be pulled a little bit up, but the mean is the one that's going to be more affected. So here the mean would be more than the median. And if it was the other way around, it would be the other way around. So this is what we call skewed. And which way does it look like somebody pulled?
Skewed to the left.
Yeah, that way, but so that's skewed right. So the direction in which it looks like somebody grabbed it and pulled, that's how it's skewed. So that's skewed right. Is that cool, huh?
My old teacher used to call them whales.
Well, you know what I call it? I call it Jabba. The Han Solo. No, okay. That's me. It's got to be a Star Wars shirt. This guy's got to agree with me. Anyway, sorry. If you've never seen that, what the hell's wrong with you? Alright, so to be honest, that is all that is in section 2.6. I mean, that's insane. That's all that's in 2.6. That doesn't mean we're leaving yet. Yes?
Why did you say the mean is less than the mean?
Oh, the mean is greater than the median. Right? Do you guys see how to read this? What does it say? The median is less than the mean. So the mean is greater than the median. Right? I like it. Oh, because this would be like the one or two people making crazy amounts of money. So like that 450 example from earlier, right? So what gets affected more? The mean does. So it's going to pull the mean up more than the median. Yes?
And if there was no outliers?
If it was perfectly symmetric, then they would be equal to each other. So they start off equal to each other, and then if I pull this way, the mean gets affected a lot more than the median does. And we know that. If I give it bigger and bigger values, then the mean is going to go up higher than the median does. And it turns around, if I pull it this way, then it's the reverse. That's all. Okay? And there are some problems in the homework where you actually get to calculate the values, and you can see that they're bigger or smaller than when they're supposed to be. Okay. The last thing I want to do today, I'm just going to take a couple minutes to kind of introduce the last section in chapter 2, because next time we'll do a handout. I'm just going to talk about the idea of it. So, I'll do this. What do I want to do? Oh, yeah. Say again? So this is section 2.7, yeah? We're crazy. Alright, let me stop there for a second. So I have up here 4 sets of data, right? So let me ask you, what's the mean of each one? 3. All of them have the same mean. Because look here, that's obviously 3, right? Let's say this is a little tiny population. So the mean there is 3. Here, what did I do? Took that down 1, took that up 1. So aren't they still going to be add to be the same number? So then when I divide by 5, I'm going to get the same number. So this mean is 3. And then I did the same thing here. Took that down by 1, took that up by 1. So the mean here is still freaking 3. And then the mean here, still friggin' 3. Alright. What's the range? What's the range of these? Yeah, they're all 3. I just got tired of making the number 3. What's the range on this one?
0.
High minus low. Highest number is 3, and the lowest number is 3, so the range is 0. It doesn't range anywhere. If you graphed it, would it be just on 3? How far does it range? Nowhere. So the range here is 0. What's the range here? 2. What's the range here? 2. And what's the range there? 4. Now, my question is, the mean is what we're going to use the most often for the center. I want to be able to give somebody 2 numbers, and that's going to summarize all of my data. So I want to give somebody a number that represents the middle. We're going to use the mean. And I want to give somebody a number that represents the spread of the data. So if I know those 2 things, where is my data centered, and how far does it spread away from that center? With those 2 things, I have a good picture of what the data is. You don't have to show me 800 data points. You just give me the mean and this other number. And I know a lot about it. Does that semi make some sense? Which one of these is obviously spread out the least? The first one. All right, so screw it. It's not spread out. Which one's spread out the most? The last one. So I put those on there because those are obvious, right? Whatever this number is that we're going to construct, it better have the smallest number for this and the biggest number for that. Now, here's the hard part. Between these 2, which one is more spread out? Maybe this isn't as hard as I thought. Yeah, this one, or the first one, or the second one? Second one, definitely. Which one gets away from its center more? The second one. So I'm going to say this one is more spread out, right? So it's all about how far you get away from the center. So don't tell me that, well, there's more repeats here. No, it's about how often you get away from the center. So whatever number we create, it better have a slightly smaller one for this than it does for this. So is the range good enough to use for this other number? It seemed to be a good candidate. That's 0, that's 4. Those are obviously different. But look, we agree that those 2 are different. That one's a little more spread out. So is the range a good enough number for this? Shit, no, it says they're both 2. It's not good enough. I need something that can discriminate better between the differences. So this thing we're going to create is called the standard deviation. It's a measure of how spread out my data is. The bigger the number is, the more spread out my data is. The smaller, the more, or it could be, it's not spread out at all. Okay, so we're actually going to create the formula next time. That's it. Yeah. Yes.
Because it has less range, right?
Yes. It just gets further away from the center. Oh, if you need that printout, come to my office. It'll be quick. If you need that homework assignment, don't forget it.